Hello students, I hope you will be doing well. So today we are just going to start the lecture that is related to the organic chemistry. That is an important topic, which is alcohol. So if I talk about the alcohols, so alcohols are those hydrocarbons which consisting of hydroxyl functional group. Okay, that is the OH. So those hydrocarbons which consisting of hydroxyl as a functional group. So that OH is actually the hydroxyl. By the name implies hydroxyl. Hydro means hydrogen, oxyl means oxygen. So what are the functional group? The functional group are the group of the compound which are used to identify any organic compound. To which uh, group does it belongs? Either alkene, alkyne, alcohol, and carboxylic. So for the alkene, the group of the compound that identify that specific hydrocarbon as alkene is carbon double bond carbon. For the alcohol, it is OH. For the carboxylic, it is the carboxyl group, that is the COOH. So that is where the functional group is. Now, if I talk about the general formula for the alcohol is that is CnH2n H2n plus 1 OH. So this is a general formula for the alcohol. By putting the values n is equal to 1 to 4, we will be able to deduce the molecular formula for methanol, ethanol, propanol, and butanol. So suppose if I put the value n is equal to 1, so that is C1H2 1 plus 1 OH. So it is CH3 OH. That is actually the methanol. Okay, that is actually methanol. So because it is consisting of one carbon, so that's why it is meth, and the enol means that is ending with the hydroxyl. That is OH, so that's why it is enol. Okay. So where the meth is actually the prefix and enol is actually the suffix. That is representing the functional group as hydroxyl. Okay, so similarly for if I talk about n is equal to 2, so C2H2 2 plus 1 OH. So that will be C2H5OH. That is actually the ethanol. So add means two carbons are present. Here you can see C2, and because it is ending with the hydroxyl, so that's why enol. So add is here the prefix and enol is actually the suffix, right? Similarly for the n is equal to 3, it will be C3H23 plus 1 OH, and that will become C3H7OH. So that is actually prop, prop because 3 carbons and enol, propanol, that is actually, right? So where the prop is actually the prefix and enol is actually the suffix. Getting that? So similarly, if I talk about n is equal to 4, So C4H24 plus 1 OH. So that will become C4H9OH. So that is a butanol. So but because four carbons are present and ending with the enol because of hydroxyl, so that is butanol. So keep that in mind for the first, if any hydrocarbon that is consisting of one carbon, it starts with meth. For the two carbons, eth. For three, prop. For four carbons, it is but. Right? So that is what the molecular formulas. So now we will be understanding how the display formula has can be elucidated and can be deduced. Okay, so okay, now so coming to the structures for the CH3OH, it can be CH3OH. That is what you can see here. The carbon is making four bonds. This is the first bond, second bond, third bond, and fourth bond. Keep that in mind. Oxygen always make two bonds, and hydrogen always make one bond. So this is the structure for the CH3OH for the methanol. This is the display formula for the methanol. If I talk about the ethanol, so it is two carbons present, each carbon fulfilling the four bonds, right? And the oxygen is making one bond. The oxygen is making two bonds, and hydrogen is making one bond. Okay. So this is what one, two, three, four, five, and 6. So there you can see 6 hydrogens present, 1 oxygen and 2 carbons. So now for the propanol, here you can see there are two possible structures for the propanol. Okay, because they are making the isomeric structures. What are the isomers? Isomers are those compounds which have the same molecular formula but the different structural formula. Okay, so now this is the first structure and now the second structure. Okay, so now you can see here, these both are isomers to each other because the OH hydroxyl group is changing the position between the carbon atoms. So now, if I talk about the naming, so first of all, I have to select the longest carbon chain. Okay, keep that in mind. You have to start the numbering from that carbon position where the functional group is attached to it or it is nearer to it. So now here you can see on the right hand side of the hydroxyl group is present. So we should have to start the numbering from that side. This is the first, second, and third. So because the hydroxyl group is attached to that carbon, So that's why we have started the numbering from the right hand side. Okay. So what it would be? It is prop 1 and all. Why it is prop 1 and all? Because the 3 carbons are present, so that's why it is prop. And 1 and all because the hydroxyl group is present on the first carbon, so that's why it is 1 and all. And the it is mentioning the position of the carbon, that is the 1, that's why it is 1 and all. Okay. So if I talk about this one, it is like you can see here, the hydroxyl group is present on the center carbon, right? So either you can start the numbering from the right or the left, it's up to you. Because the hydroxyl, according to rule, you have to start the numbering from that carbon where the functional group is attached to it or the functional group is nearer to it. So now here you can see the functional group is nearer to both of the sides. So you can either start numbering from right or left, it's up to you. I am starting the numbering from the right hand side. So this is the first, this is the second, and this is the third. So now here you can see it is prop because of the 3 carbons are present and because the hydroxyl group is present on the second carbon. So I will mention the position of the carbon atom, that is 2 and enol. So that is the prop 2 enol. Is that clear? So both of them are isomers to each other. Both have the different structural formula because the hydroxyl group is changing the position from the first carbon to second carbon. So that's why it is making the different structure. And because the molecular formula is same, so that's why they are isomers to each other. Both of them are isomers to each other. Right. So if I talk about now the butanol. Okay, one thing more. Prop 3 and all is not possible. The reason is that because we are not able to start the numbering from the left hand side if I talk about this structure. This is the wrong way. Because the hydroxyl group is too much far away from that position. And it is not according to the rule. Because according to the rule, you have to start the numbering from the dead carbon where the hydroxyl group is present to attached to it or nearer to it. So because from the left hand side carbon, the hydroxyl group is too much far away. So that's why we cannot be able to start the numbering from that side, left side. So that's why the prop 3 and all is not possible. Now coming to the butanol. So it is also making the two isomeric structure. So 3 carbons, each carbon is fulfilling the 4 bonds, right? Sorry. So 4 carbons, so it is but, and because we have to start the numbering from the right hand side because the functional group is present to it. So first, second, third, and fourth. So it is basically but 1 and all. Is that clear? So similarly, another structure that is can be possible. So now here you can see here, if I select the longest carbon chain, so where we have to start the numbering? We have to start the numbering from that position where the functional group is nearer. So now here you can see the functional group is, that is hydroxyl group, is far away from this. Sorry. Now you can see here the functional group is too much far away from the left side carbon, but it is too much nearer to the right hand side carbon. So that's why according to rule we have to start the numbering from the right hand side carbon. So this will be the first, second, third and fourth. So it will be but 2 anol. It would be but 2 anol. Now the but 3 anol is not possible because we cannot start the numbering from the left hand side carbon because the functional group is too much far away from it. So that's why only two isomeric structures are possible, that is but 1 anol and but 2 anol. Why they are isomers? Because there is a change in position of the hydroxyl group from the first carbon to second carbon. So that's why they are isomers and having the same molecular formula. So that's all about this lecture. Thank you so much.